In today's video, I want to talk about Retrieval augmented generation. This is what the final product will look like. It is an interactive chat app that allows us to ask questions, send them into a large language model pipeline, where also the question is used to retrieve information from a vector store that the large language model then uses in its response. And the best thing is at the bottom there's a source link, which will give us a link immediately to a file that is saved on SharePoint, which is the source for what was used in the response. Let's start with understanding what RAG actually is. It's a technique that combines retrieval of information with generative AI models. And this improves the generation of content by these large language models as they are enhanced by external knowledge that they are not necessarily been trained on. You may also have heard about this as chat with your own documents, as you literally tap into data that you have ingested into a database. This technique can significantly improve the accuracy of responses, especially if you can keep your vector store up to date efficiently by adding new data to it as time goes by and removing data that is outdated. A very practical use case I can see is an internal chatbot that leverages documents such policies and product presentations to significantly enhance the efficiency of your internal staff to find the right information when they need it. Let's now talk about the app that I want to build today. The app will have two components. There's the RAG ingestion workflow, and then there's the RAG chat app that will use the information to provide them to users. The ingestion workflow will access documents stored on SharePoint, ingest them, so create the vectors, create also links to the SharePoint page, and then save them into a vector store. In the RAG chat app, we will have a chat user interface where a user can send a message. That message is first sent to a retriever to retrieve data from the vector store. That is then passed to a large language model, which generates a response to the user that is then rendered again in the chat user interface. To start with, let's take a look at the SharePoint setup. I have created two folders inside an empty document library. One is called Docs, so that is the final destination of any of the documents that we process into our vector store. And the other one is named Knowledge Ingestion. So that is the folder where I, or theoretically anyone else with access, can place documents that they want to add to the vector store. And our application is then going to take that away and make sure that after processing, so after extracting all the useful information and make it usable in the vector store, that it gets transferred into the documents, into the docs folder, and then we also add a link directly to the document in the docs folder so that we can use that in our chat app. Let's take a brief look into the folders, and we start with knowledge ingestion. There's one file in it that I will use for testing that the workflow works. It's one of the outputs that the Game of Note teams in the quarterfinals produced, and it has some text and images in it. The docs folder for now is just empty, and we will change that as we develop this workflow. So to start with, we authenticate with Microsoft. I'm actually using the deprecated version because this one allows me, after logging in, to store the tokens in a file, and that makes this work on the KNIME Community Hub on a team plan as well. The next node is the SharePoint Online Connector. In this node, we need to provide the URL to our SharePoint site and also choose the working directory. I've chosen the Documents directory. The next node that the SharePoint Online Connector is connected to is the List Files and Folders node. And this node is configured to show us the files in a folder, and we point it to the knowledge ingestion folder where we store any new documents that we want to add to our vector store. After that, we have an empty table switch, because if we want to schedule this workflow, we need to cover scenarios where potentially there are no files in that folder. If there are no files, then the bottom branch activates, which leads straight to a breakpoint, and this breakpoint has a configuration to trigger when it's in an active branch. So it will be active if there are no files in that ingestion folder. And I've set a custom message so that this also shows upon execution in the KNIME Hub. If there are files, then we are activating a transfer files in brackets tables node. This node also gets the SharePoint Online connection and also the files from the list files and folders. This is configured to use the path, which is the path to the files in the folder, as the source column, and it moves them to the current workflow data area into the folder temp data. This is required so that we can process these files inside a Python script node later. We've also configured this so that the files in the source folder are being deleted. So that way we make sure that we are not double dipping all the time when this one gets re-executed. Once the files have been transferred, we have another list files and folder node, and this time we are listing the files that just have arrived in this temp data folder in our current workflow data area. With that, we now get a little bit closer to actually processing those documents. Above, we grab extract context properties node, and this node gives us the current workflow absolute path. So with this absolute path in the next node, in the column expressions node, we can actually create a path to our current workflow data area by using the built-in formulas that you can see on screen. And we do that to generate a path type path and also the path as a string. After this, it's time to use the Markdown package from Microsoft to parse all these different files that might have been in the folder. To make this work, I've set up a custom Conda environment that includes this package. By using my workflow, you won't have to do anything yourself other than setting up Conda, as long as you are executing this locally. If you don't execute this locally, but just on the KNIME Hub, on a team plan or on the business hub, then this node has all the information to set up the environment. It's worthwhile noting that if you use Conda environment propagation on the KNIME Cloud offerings, then this node will set up an environment whenever the workflow is triggered. So that will consume some time for workflow execution. The next node is the Python script node. I've prepared a Python script that takes the contents of the files that now have been saved on the current workflow data area in the temp data folder and extracts their contents as Markdown. Once that is complete, we send it to a column expressions node, and this column expressions node does nothing else other than adding a timestamp. So that is the current date and then the current time in terms of hours and minutes. Once this is done, we branch down, because now that we have processed the files, we actually want to move them out of the temp data folder and back to SharePoint into the folder that will finally hold all the files that will be available in the vector store. So for that, we first connect to the current workflow data area. There's a workflow data area connector node for that. And then we use a transfer files node again. And this transfer files node is configured to take all the files that are in the temp data folder and to move them to SharePoint, to our target folder for storage of all the documents. With that done, it is time to use another column expressions node. This column expressions node creates the relative path for SharePoint where the documents are being stored, and it removes the part of the path that has documents / in it. And that is required so that in the next Python script node, we can combine a SharePoint base URL, which for now I've hard-coded in the Python script, with an encoded part of this relative file path. So encoding means that if there are spaces in the name, we handle them so that they can work in a URL. And this then outputs a link that can directly lead us to the documents that were processed, as long as you have permissions to access it. Next, we join the bottom dataset, which contains the clickable links, and the top dataset, which contains our converted markdown and the timestamp, and that we join on the path column that both of them have in common. That is the path to the document whilst it was on the current workflow data area in the temp data folder. Once we've joined that, we send the new data set to a text chunker, and this text chunker is configured to take the converted markdown and chunk it into chunks that have 1,000 characters, and we make it overlap by 150 in between chunks. And this helps us to sort of optimize our retrieval augmented generation. That data set we then send to a table manipulator, and the table manipulator allows us to, let's say, filter and also rename columns. And that is just to remove a lot of the unnecessarily helper columns, like the path to the current workflow data area and so on and so forth, and to rename our chunk column to information. So this data set finally can be sent to a text embedder to generate the embeddings, so the vectors for each of the chunks that were generated. Before we can do that, we need to set up our OpenAI connection. So we start with a credentials configuration, which holds the API key in the password field. We pass that to an OpenAI authenticator to authenticate with OpenAI. And next we connect that to an OpenAI embeddings connector, where we select the small embeddings model as our model to generate the embeddings. We connect that to our text embedder, and that will make sure that any file that has been added to the knowledge ingestion folder will now get embeddings like vectors created. We'll notice now that there is a second branch from the credentials configuration to a try-catch construct. And that is, we want to also update any existing vector store so that we don't have to create embeddings for files that were already processed again. So in between this try-catch, we try to read a model file, and if this model file exists, then we retrieve the data from the vector store using the vector store data extractor, and we then concatenate this with the new embeddings that come out of the text embedder. So if that part errors out because it's the first time that we are running this workflow and therefore there is no model file to read yet in the location that we've set, then we actually take the output of the text embedder, and the row filter is configured to only keep rows with a row number that is smaller than 1, which is 100% none of them. So we send an empty table to the bottom port of the catch errors part, and we then concatenate that. So that way we have an empty table, but the concatenate will still work and we don't get an error. And after that, we finally can create our vector store. For that, we connect the OpenAI embeddings connector to the FICE vector store creator. And in the bottom port, we connect our table that has the concatenated embeddings from any existing embeddings and also the ones that were newly embedded. So in this FICE vector store, it is also important that we select the metadata that we want to keep. So in the top, we select the information column as document column, the embeddings column holding the vectors as the column named embeddings. And then below that, we include the file type, final URL, and the timestamp. The last node in our workflow is then the model writer. So this model writer writes this vector store relative to the current workflow, so into the same folder as our current workflow is saved, into a file named vectorstore.model. And this vectorstore.model file is exactly the file that we are trying to read inside this try-catch block. So with these The reason why the file, the vector store model file, is stored relative to the current workflow and not in the current workflow data area, it's very simple. We will have a second workflow that we will cover in a little bit, which is supposed to use this vector store model file as input, and that will be our chat app that allows us to interact with this vector store and to leverage the information. Let's now get this deployed and process some files. I've uploaded something to SharePoint. There's a PowerPoint, which is an excerpt of the level 4 text processing lecture slides that I've borrowed from KNIME. Thanks for that. As you can see, some images and some text. Then there's also a Word document, which is the course outline for exactly that course. So a table in a Word document with some bullet points. Then there's also a CSV file with some player data from the Kicker Interactive Manager game. I've shortened that though. And there's the document that we saw earlier and a course outline for a KNIME for Finance course that I might develop in the future. Let's now switch back to KNIME, reset the workflow and save it. Let's reveal it in the Space Explorer. It's still on my local space. And let's then upload it to the Community Hub on my team plan. So I go to the Finnovation Flows team and put it to the test space 3. And now it's being uploaded. Now I switch to that space and I delete the vector store model that was created there when I was testing this whole pipeline. Now we right click and open this in the hub. And after a while, the browser opens. And here you can see the workflow that was just uploaded. And if I click on Run, the execution side pane opens. I click on Run again. And now we wait. Once the little green check mark appears, I can scroll down and click on Inspect. That opens a new window where I can monitor live how my workflow is executing. Let me make a bit more space and then zoom in. As you can see, it's a Conda propagation node that's currently being executed, so that may take a while. So I will pause and I'll be back once it's done. So now it's on green and you can see how more nodes are being executed. Now the embeddings are being grabbed from OpenAI, and you can also see that the URLs and timestamps have been created. The workflow just finished executing. So let's now take a look. It's done. The model has been written. Let's go back to KNIME desktop and refresh. I'm still on the hub space. There is the vector store model file. That's great. Let's check the folders. Knowledge ingestion empty. And the documents are all in the docs folder. Awesome. Let's check whether the links are working. Let's grab one from one of the nodes. Let's select it and copy it and paste it straight in the browser. And there you go. It's opening. Perfect. With that, there's one thing left for me to do. Let's go back to my team and let's stop the execution for now so that no resource and execution time is wasted. Great. So the next step is to modify the chat apps that KNIME already has prepared as examples and to hook them up to the vector store. Let's now take a brief look at the chat apps that I've built, and I want to show you first the starting point. If you search for Rec Chat App KNIME, then you will likely end up on the KNIME Hub with this example data app for building a chat interface that can do retrieval. You can see there's a vector store creator down here. So I've taken this as a starting point for myself to then integrate the vector store that I've saved as a model file. So let's go to KNIME and here's my final output. As you see, I'm just reading the model file with the model reader node. It's important that both the OpenAI authenticator as well as the model reader node receive the credentials where there is the API key. As the chat model, I've selected GPT-4o Mini, and I've changed that we have up to 1000 tokens in the response. So then there's this app which receives both the chat model connection and the vector store model. And in this data app, I'm not going to cover this in detail, but what I've implemented, I have implemented my own data app header. Unfortunately, the data app headers that are JavaScript based, they don't really work on the hub. So I've changed that. And what I've then implemented is checking whether the initial conversation is empty so that we are not sending any unnecessary queries to the large language model. We also, from the vector store, retrieve the links to the documents on SharePoint. And then these links are also injected to the AI response. And at the very end, I've created a sort of chat-like view. It will look like a chat app, but there's just a table being formatted. And in that view, we will also have links to the documents that were found during the retrieval stage. So let's now go to the KNIME Hub and test this. So here's the chat app, and I will now run this. And here is the, to start with, empty chat interface. You can see the AI asks how they can help. And let's now ask a question, maybe about that visa PDF document. Well, let's ask a simple question: what the best country for an Australian citizen is to apply for an EU visa for? So based on the provided context, the best EU country for an Australian is Austria. It has one of the highest approval rates for visa applications. And it gives us a source, so I can open that. It opens up the source document as intended. So let's try one more question, maybe about text mining. Another simple question: what is text mining all about and how does it work? So the chat app has been updated. We still have the source. We see the new message. And now we get a lengthy response about text mining and another source file, which opens exactly these slides that we have ingested. So let's now check out the current execution. So it's still running, and I'm especially interested in what's going on here. So here we get our user message. That user message is sent to the vector store, and the vector store returns a couple of documents, so we can look at them here. They all come from the same PowerPoint, and this information is then down here passed to the chat model, where the response is generated. And then further down here, we see that the overall conversation is split up into this table, and we have the source column, and that are then the links that we see at the bottom of the chat bubble. So this is how the data app and the retrieval works. So what I now want to do is I actually want to close the current session, and I want to ingest a new file. So this is the Python Node extensions guide. So how you can build an extension in Python. It's 62 pages, and I now want to ingest this. So let's go back to the space, go to the ingestion pipeline, and let's execute that. While this is executing, let's also check out, or better inspect, the current run. So right now it's transferring the file. It's still propagating the environment, fair enough. So now it's done, files are transferred. Now everything is being embedded. So this 111 rows, so that may just take a little moment. By now we should see the document. Here it is, it's been moved, and ingestion is empty, so that would have worked. Our vector store has been updated, and now everything should be okay for us to run another chat app run. So let's start this again. This startup should be a bit quicker now that the executor is running. So there we are. Let's ask a question about how to bundle a Python-based extension. And while it's executing, we can also inspect this again. Yep, It has definitely found the right document, and now the view is ready as well. This is actually correct.